Hey guys, this is video 11.5. Today we're going to talk about solubility rules. So this is something you will absolutely see on your Regents exam. The good news is in this class you are given a table that has the solubility guidelines for aqueous solutions, which is a table F in your reference packet. So you should have that out because you might want to jot down some of these notes that we're going to take actually in your reference packet so that as you're doing practice you don't have to be flipping necessarily back to your notes, and then as you're studying for the Regents exam you'll see them on your personal reference table that then you can then copy them and kind of remember them when you get your new one in June. All right, so this video is going to kind of be talking about the solubility rules, and then we're going to kind of take it slow over the course of a few videos, kind of how we're going to apply them. We're going to get into dissolution of solids in the next one, and then we'll eventually get into the net ionic equations where we will actually use it. So we basically, when you look at table F, you've got kind of two categories. You've got ions that form soluble compounds on the left, and you have ions that form insoluble. So right there's two terms you have to be familiar with. So if you haven't done the vocab and you haven't really learned the vocab, not just written them down, but made flashcards and are studying them, this is where you might get confused. Okay, soluble means dissolvable. Okay, now in terms of a state of matter, that means it's going to be aqueous. Okay, it's going to dissolve in water, which is what aqueous means. So it's going to form a solution. Insoluble then is the opposite. That means it's not dissolvable. Okay, and how we can see that visually when we make do a reaction or we try to put something into solution is it's going to be a solid state of matter. Okay, it's going to stay in that crystal form that we added to it. It's not going to split up into ions. It's not going to dissolve in the water. It's going to just stay as it is. Okay, so that's kind of the first piece you've got to kind of look at. So keep that in mind. So when we take a look at these categories in this table, exceptions to the soluble rule means that these are going to be solid. Okay, so if normally these ions are soluble, meaning they split up and form aqueous solutions, if you have an exception to that rule, it's going to be a solid, meaning it's going to be insoluble. On the flip side over here on the right, if something is insoluble first, so notice these are the ions that form insoluble compounds, their exceptions would then be soluble, making them aqueous in terms of their states of matter. I'm going to rewrite that because I don't like the way it looks. Okay, so that's kind of the big thing you've got to kind of be familiar with. You've got to have to use these a lot. It's going to take practice. Okay, so for some of you it may take 3 or 4 practice problems to kind of get a good grasp and feel of it. Some of you it may take 10 or 15. Okay, you've got to put that time in and not just think, oh, I can just kind of get by and kind of guess at it, because this is something, guys, that can be challenging at first until you get used to it. And then it's not too bad. It can be long and daunting, but it is a process. Okay, so take a look here. What we're going to look at, if you notice, most of the ions that are listed here, guys, most of them are negative, which meaning they are anions. Okay, so if we think about compounds, which comes first in a compound, the anion or the cation? This is review. You should be able to answer this question fairly quickly. The first one is always the cation. The positive always comes first when you have a compound. So what I've encouraged you guys to do already this year, and you're going to see me do it here, is that you're going to split the compound. How do we split compounds up? This is going back to our reactions unit where we were predicting products, and we're going to be doing that some more here in this unit. So it's kind of coming full circle, reviewing things we've already learned. It's been a little while. So you draw the line and you look for capital letters, okay? So what I typically do when I'm looking, okay, to figure out is something soluble or is it insoluble, I want to look at my anion, okay? Because most of these ions listed here are negative, they're anions, so that's going to be kind of the piece that I'm going to look for. Group 1 ions are positive, okay, and so is ammonium. Those are the only positive ions that we have on this table. Everything else are anions, unless they're the exceptions, okay? So let's take a look here at some practice. Let's kind of jump in. We're going to use our solubility solubility rules to determine if the following substances are soluble or insoluble. So here's the process you should be going through as you do practice like this. So here's my first one, NaC2H3O2. You should be able to name that. Guys, if you can't name that compound, you've got to go back. It's something you need to review. You've got to be able to name compounds in this class. This is sodium acetate. So how would I split that up? Look for my capital letter. So Na, okay, the second capital letter, bam. So over here I've got sodium, here I've got acetate. So now I'm going to look at my anion, which comes second. Okay, polyatomic in this case. So I'm going to look over here. Which category does it fall into? If I look for acetate, oh look, acetate is right here. That means these are ions that form soluble compounds. Are there any exceptions? No, there's not. So anytime you see acetate, guys, it's going to be soluble and it's going to become an aqueous solution. So we're going to label this as S for soluble. All right, so that's the process we're going to go through. Let's take a look at letter B. Split up my compound. Lithium sulfate. So I'm looking again at sulfate as my clue to kind of figure out which category it falls into. So I'm going to go look up here. I'm going to search for sulfate, SO4. All right. Oh, look, here it is. So again, it's under the soluble compounds list, but notice sulfates have some exceptions. If it's paired with silver, calcium, strontium, barium, or lead-2, notice it's lead-2, not lead-3 or lead-1 or something else like that. It's lead-2. Okay, if it's paired with one of those ions, it would be insoluble. So we've got to look, is this one of the exceptions? No, because this is lithium. Lithium is not one of the exceptions, so that makes this compound soluble. If it was one of these exceptions, let's say it was calcium, then it would become insoluble because it was an exception to our rule. Okay, so I want you guys to pause this video. I want you to go through and fill in and try your best at identifying the solubility of letters C through J. All right, so I'm going to kind of go through this. We will check your answers here. Oh, notice this is in words. You've got to be able to write it out. Guys, anytime you have words, you've got to do the crisscross method. So we've got barium, which is a 2+. We've got hydroxide, which is a 1-. Crisscross those over. You've got to be able to go from names to formulas when we get to net ionic equations. If you don't do it correctly, then everything will be messed up. So our formula here for barium hydroxide looks like that. Excuse me. Split up your compound. Okay, I'm looking at hydroxide. Where is hydroxide on my list? Okay, hydroxide is over here now. It's on the insoluble compounds list. So don't just assume, hey, right away that it's going to be insoluble. Look at your exceptions. When it's combined with a group 1 ion, calcium, barium. Oh, look, barium's an exception. So if barium is an exception to the insoluble rule, that's going to make it soluble. Okay? So moving on to the next one, AgCl, split it up. Cl is what I'm looking for because that's my anion. That's what typically are here. Look, oh, look, that's under the halides, the halogens. Cl-. Are there any exceptions? Yes, silver is an exception. So if it's an exception to the soluble rule, that's going to make it insoluble. Okay? So for the sake of time with this video, I'm going to kind of go through and I'm just going to put up the solubilities. If you have questions, if you get anything wrong, ask me in person in class and we can kind of talk about it. MgBr2 is soluble. K3PO4 potassium phosphate is also soluble. Calcium carbonate is insoluble. Sodium chloride, you guys should all know that even without looking at those. That's table salt. You've mixed that with water before. Lead-2 iodide. This is actually lead-2. So if you got this one wrong, you got to look at the charge. Okay, so Pb is a transition metal. It could be a couple different charges. So you've got to look at iodine. Iodine, guys, is a -1 charge. But if I have 2 iodide ions, okay, that's a total charge of -2. That means lead has to be +2 to balance it out. If you forget how to do this, go back and look at your notes when we did naming, and we figured out the transition metal charges way back when. HNO3, this is nitric acid. That is soluble as well. So your task now is to go through, circle which of the following compounds are soluble in water for the first problem, and then which are insoluble in water, and then you can check your answers in person.